Hi everyone, my name is Chris Regassa,
My name is Kelsey Bakshistari.
My name is Andrew Lee.
and in this presentation, we'll be talking about our senior project, Cal Poly Smart Parking.
We will be using QR to improve Cal Poly's parking system for all users.
Our technical advisor is Dr. Tao Yang, and he has been a pleasure to work with these past 2 quarters. Alright, so here is our agenda for this presentation. We will be starting off with a background of the parking issue on campus, move into the problem statement, methods, design, and results of our system, then finally wrap up with our conclusion and future research. So currently, Cal Poly is experiencing a period of major growth in student population. When we were freshmen in fall 2012, enrollment was 18,679 students. Now, as seniors, Cal Poly's enrollment has increased to almost 21,000 students. Currently, Cal Poly's master plan has a target of 25,000 students by 2035, a 33.8% increase. So Cal Poly has taken multiple initiatives on solving the problem of overcrowding within the student body. We see this as efforts have been made in constructing new student dorms, as well as a proposed expansion of the University Union. However, Cal Poly has not formally addressed the issue of parking on campus in both its current and future state. So our problem statement. Cal Poly parking lots become congested during peak campus hours, causing delays for the thousands of students and faculty, staff, and guests that visit the campus daily. We would like to develop an optimized parking solution to reduce parking lead times and roadway congestion on campus, especially with the student population projected to increase in the coming years. In addition, we defined some constraints of our project, including a low project budget and a development period from March to the end of May 2016. These constraints would influence our parking system choice significantly. Our first task in the project was to explore various existing parking technologies. RFID was the first option we explored. We contemplated a fast track-like system where an overhead scanner would scan passing cars at the campus entrance. However, this was heavily cost prohibitive and could not be explored within our project budget. Next, we experimented with NFC. It was a slightly less expensive option as we opted to utilize users' phones. However, we were technologically limited due to the fact that Apple NFC tags, as of 2016, are locked and not open to developers. Finally, we concluded that the most feasible technology within the scope of our project was the use of QR codes and a database. Anyone with a smartphone is able to scan QR codes, and the cost of implementation is minimized. However, we still see some setbacks in our tool, such as the possible use of the phone while driving.
30 Cal Poly students with parking permits across different majors were surveyed to determine parking lot popularity. Our group decided to focus on a parking lot that primarily provides parking for students due to the fact that faculty and staff permits have the ability to park in both these general lots and additional staff lots. Students were asked what parking lot they first searched when arriving on campus. This table illustrates the various responses of these students, with 56.7% of students responding that they began their search at lot H12. Our group decided to focus on this lot. This is the parking lot closest to the Highland campus entrance in Building 192. Our current design for the smart parking tool uses smartphones and everyday commodity to reserve and update parking spot availability. First, when a driver claims a parking spot, they will scan the specialized QR code for that spot, indicating it is taken. The QR code contains a unique URL for that spot that, when accessed, automatically updates an interactive database ran through Microsoft Access and ASP.NET. When a driver is ready to leave, they will scan a similar QR code that will open the spot on the parking database. The value of our tool is the real-time information on parking availability on campus for other drivers. Instead of wasting time vulturing multiple parking lots in search for a spot, a driver would instantly know what parking lots have spots available. We hope this tool will reduce the amount of time wasted in searching for parking spots.
So this is the main page of our web application as seen on an iPhone. This is the web page where users can identify and locate open parking spots. The picture on the left is what you see when you initially open up the web page. You can see that the Google map is automatically centered around parking lot H12. since we found it was the most popular parking lot for students as discussed in our survey. You can also see a bunch of little green pins. Each of those green pins identify an unoccupied parking spot so the users can immediately see the exact location of the open spot. However, users can also find the exact number of open spots by clicking the drop-down box on the top of the homepage, as you can see in the middle picture. When clicking this drop-down box, the number of open spots appears on the bottom of the phone. In this case, 396 spots are available. And lastly, like all Google Maps, you can zoom in to get a better view of certain areas on the parking lot. You can see an example of this with the picture on the right. So once a user locates and parks in an open parking spot, he or she would be able to see two QR codes as seen on the left-hand side of this slide. Ideally, these QR codes would be displayed on a small sign posted at the parking spot they're in. The user would simply scan the check-in QR code with their smartphone and would automatically get directed to a check-in page for the spot they're in. In this example, the check-in QR directed the user to a check-in page for parking lot H12, spot number 1. Once a user verifies that this is the correct spot, they would hit confirm. After confirming, the users are directed to a confirmation page, as shown in the next slide, and the database is updated. Each time the database is updated, the home page is refreshed where spot number 1 is now occupied. Likewise, if a user is leaving the parking spot, he or she would scan the checkout QR code and be directed to a checkout page. When the user confirms that they are leaving the spot, the database is updated and the home page is again refreshed where spot number 1 is now available. And lastly, here's the confirmation page that users are directed to after hitting the confirm button while checking in or checking out of a parking spot.
We will now show a demonstration of our CPSP tool.
So this is the home page. When you first open up the page, it's centered around parking lot H12, the most common lot that students use. If you zoom in here, you can see a bunch of green dots or pins that are fixated on certain parking spots, and that basically tells you whether or not it's occupied or not. And then if you want to hit this drop down, it actually tells you the exact count of open spots. In this case, there's 391. And for our demo purposes, I want you to look at this right here. This is parking spot 406. There's a green dot there, so it shows that it's occupied or unoccupied. So we go to our Red Laser app here. This is a free app that you can download on the App Store. It was unoccupied, so we're going to go ahead and check in. So this is our QR code for checking in. We're going to scan this one. We open the URL, hit yes. Here's our, see it says here you're parking in lot H14, spot 406. We're going to hit confirm. There's our confirmation page. We go back to the home page, and if we look now, parking spot 406 no longer has a green pin there. There's supposed to be a green pin right there. And then lastly, the count was 391. Now it's at 390. And then, so we're going to go ahead and do the same thing, but instead we're going to check out instead of check in. So this QR code is check out. We're going to scan that. Sorry, it's a little blurry. There you go. Open URL. You are leaving spot 406. Confirm. Go back to our home page. You can see the green pin has appeared again, indicating that the spot is now open. The count was 390, and now it's back up to 391. So, thank you.
30 Cal Poly students were approached with the CPSP tool. The first question asked was, do you find the CPSP tool useful? 86.7% of students answered that they believed the tool was helpful. The reason some students responded that this tool would not be useful was because they did not own a smartphone, so they would not be able to use the tool anyways. The second question in the survey was, how much time in minutes would you estimate this tool would save you when finding parking? The average time that students estimated they would save by using this tool was 13.2 minutes. Upon completion of the CPSP project, the following conclusions were developed. QR is a practical and cost-effective technology for smart parking purposes. It has major cost advantages over more advanced technologies such as RFID and NFC, which require significant implementation and annual cost to maintain. The CPSP system has the ability to provide live parking results to end users, provided that parked users responsibly check in and check out of their spots. Students find the CPSP tool beneficial, especially when searching for a parking spot during Cal Poly peak hours.
So, as far as future research, we think that our project in general is still within its development phases, and there could be a lot that can be done with future quarters. First is to integrate it with student payment account. So, for example, if a user was to come into a parking spot and would scan the QR code, it would automatically charge them based off of how many minutes that they're checked into a parking spot on their student account. Secondly, to expand to all general parking lots and test for practicality on a larger scale. So for our project, we only use parking lot H12, but obviously to test for practicality, we would have to expand to all parking lots on Cal Poly's campus to see if it's actually feasible. Three is to add security features. So every time that a person would check in, maybe they would have to log into their Cal Poly portal if they were a student, or some sort of verification page if they were a guest, to make sure that other people aren't tampering with the check-in, check-out pages. And lastly, to make our homepage dynamic, in this case, our homepage is refreshed in time intervals or every time a parking lot or a parking spot is updated. But it would be nice if we added some JavaScript code to make it so that the whole homepage wouldn't refresh and just the green pins would update whether or not someone checked in or checked out. And this concludes our presentation, so thank you for listening.